In this video, I'm going to talk about small signal amplifier with CB configuration. How do we know it's a CB configuration? See, our input is connected to the emitter. This is the emitter, and output is connected to the collector. Okay, so emitter is connected to the input, collector is connected to the output. So the common terminal must be base. So that is the reason we call this as CB configuration. So this is a CB configuration. So there are two parts. First part is we have to do the DC analysis. Second part is do the AC analysis. So while doing AC, first we need to do the DC analysis. So while doing the DC analysis here, what I did, I removed whatever connected to the base. I want to keep it as a one source and one resistor. So I just don't want to have this second resistor. So I cut the wire right there at base and connect. This is the circuit you're going to see, and I found the Thevenin equivalent circuit. So I found the Thevenin equivalent voltage V Thevenin, and I found the Thevenin equivalent resistance R Thevenin, which is 5 volts and 40 kilo ohm. So the circuit is going to be on the base side is going to look like this. So the 40 kilo ohm and 5 volt. So I'm going to do the DC analysis here. The beta value is given as 100. So I'm going to do the loop equation right there. Minus 5 plus 40k IB. So the current passing through is IB plus 0.7. The voltage drop here is 0.7 because I'm assuming this transistor is working in active mode of operation. So plus 0.7 plus 2k times IE. The current passing through this is IE. Okay, we know that beta is IC over IB, alpha is IC over IE. We know beta, so alpha must be beta over beta plus 1. Based on this, I found alpha, and based on that, I end up finding the IC value as 1.77 milliampere. This is the current we needed to proceed with AC analysis. Now, before moving to the AC analysis, we want to make sure that this transistor is in active mode of operation. So make sure that your VCE is greater than 0.3 volts. So I found VC, which is 15 minus 5k times IC. So 15 volts is right there. This is VC. So 15 minus VC must be 5k times IC. By using that formula, I found VC value as 6.11. Same thing at VE. At VE, this is the voltage at VE. So I know IE current, I know the 2K. So based on that, I found VE. So VCE is VC minus VE. VCE equal to 6.11 minus 3.57. So definitely it is greater than 0.3 volts. So the transistor is in active mode of operation. Once it is in active mode, you need to find the transconductance Gm. The formula for that is IC over VT. 1.77 milliampere, that's IC we found. VT is the thermal voltage, which is always 25 millivolts plus or minus. So I found the GM, that's the transconductance. So it's a Simon. RE is alpha over GM, and I found that value as 13.98, and R0 is the output resistance of the transistor. Here we call it as input resistance of the inside of the resistor. I'm not talking about the whole circuit. So the resistance connected to the E. So that's RE. R0 is connected always between emitter and collector. We'll use this when either of them, either emitter or collector are grounded, or both of them are grounded. Now I'm going to do the AC analysis here. So the circuit is going to look like this. So this is 40k. Now I'm going to replace this internal transistor with the equivalent model. So I'm going to use the T model here because the emitter is not grounded while doing AC analysis. So that is the reason. So T model, I'm going to do the T model here. So this RE is right there, GM times VBE, that's a current dependent current source. So here I'm ignoring R0 since either emitter or collector is grounded. So either of them are grounded. So our goal is finding the gain AV. AV is nothing but V0 over V input. So let me find V0. V0 is the voltage at this point, anywhere on that line. So can I say, these two are in parallel, RC parallel with RL. and the current going through this is Gm times VBE, but V0 is right here, so that's supposed to be positive, but current is entering there, so plus and minus. So this must be a negative value, so that is the reason I have negative Gm times VBE RC parallel with RL. Now I'm going to replace this VBE with input voltage. So here is my input is right here. This is my V input. So what I did here, I moved this base resistance RB from the base terminal to the emitter terminal. So when I move it to the base terminal to the emitter terminal, this is what it's going to be, RBB over B plus 1, or sorry, beta plus 1. So that value is 396.03 ohms. This is the equivalent resistance when looking from the emitter side. Okay, so all I did, I transferred the resistance from the base, moved it to here. That makes it easier. So I know the voltage at this point is 0, the voltage at this point is Vn. So I used the voltage division rule. Okay, so voltage here is Vn. So according to the voltage division rule, VB equal to negative Vn, because VB is top one is positive, bottom one is negative, but input voltage is here. So since that's a negative value, negative Vn times same resistance over total resistance. So RE over RE plus RBB over beta plus 1. So based on this, I found VBE equal to negative Vn times 0.034. I'm going to substitute it here. So once I substitute it there, I end up with V0 equal to 5.35 Vn. Please verify calculations. So all I did, I substituted all the values, RC value, RL value, GM value, and that's what it is showing here. And then substituted VBE value, so I end up with V0 equal to, so the AV is nothing but V0 over Vn, which is 5.35 volt per volt. That is the gain. So the gain is only 5 times higher than the input. So AV0 is the gain at no load. So here all I'm doing, I'm removing the load, so the RC parallel with RL, right? So if I remove this load, we'll end up with only RC, and substituted that, we end up with gain is 12.036 volt per volt. Okay, that is the gain. Now I'm going to find the input resistance. So input resistance, I'm looking the circuit from here, input terminal. So here is a V input and the ground, second terminal is. So when I simplify the circuit, by the way, I didn't draw everything right. So those are grounded, that's grounded there. So when I simplify the circuit is going to be look like this. This is RC, that's R. Okay, all I'm finding the resistance from the input terminals. So when I look at the input terminals, I can see these two are in series, that series combination is parallel with this. So we'll end up with the R input equal to 340 ohms. Now, to find out output resistance, so same thing here, I'm looking at from here before connecting the load resistance. So remove the load and look at the circuit from the output terminals or out. Since there is a dependent source, I'm going to connect a 1 ampere source to find out how much impedance that is producing. But at the same time, here is my VB, remember that. Okay, I'm not connecting anything to these terminals, so my VB equal to 0. So current passing through this must be 0 milliamperes. So my R out must be same as RC in this case. Okay, so my R out here is RC. Now overall gain, I'm going to find the overall gain here. GV equal to always AV times R input over Rn plus R sig. Okay, so AV is 5.35 times 340 over 340 plus 50. So I found GV overall gain is 4.66 volt. Okay, so when you draw the waveforms, say for example, here is my input signal. Say it's 1 millivolt maximum value. So it's just like 1 sine omega t millivolt. Okay, that's the input value. Now my output is going to be, so according to GV, I mean overall gain, my output is only 4.66 volt per volt, and it's positive, so it's going to be on the same side. I mean, it's not inverted, I meant to say. So here it's 4.66 millivolt, here negative 4.66 millivolt. Okay, that is my output signal. Now sometimes I might ask you to include the DC value too. Now my output is connected at the collector, and we found that collector current or collector voltage as 6 point something while doing the DC analysis. So I think while doing the DC analysis here, 1 second, I found VC right here 6.11 volt. So here my VC is going to be there too. VC is 6.11 volt. Now my output is going to vary based on that voltage. So here is my output. Okay, so this is 6.11 plus 4.66 milli. Okay, so it's not too much difference though. And here is 6.11 minus 4.66 milli. Okay, this is my output with respect to the DC. I mean, with including the DC value. Okay, I will stop it here. In the next two example, either I'm going to solve one more CB configuration or CC configuration. Thank you guys.